In this tutorial, I'm going to show you how to quickly annotate a large DNA copy number profile on SegAnnDB. So here I'm showing you a scatter plot of neuroblastoma copy number profile of all of the chromosomes in the genome. And you can see from the green lines that the default model has not been annotated yet. So what we can see though on the zoomed out plot is several interesting details. By default, the model detects a loss on the first part of chromosome 1. We can indicate that with a loss annotation in blue. Since that's the first annotation, the system colors all of the rest of the segments same annotation, but we can give the other part of chromosome 1 a normal annotation, and so then the system will color the rest of the segments normal or loss. And so and we can see in chromosome 2 there's amplification, so we can zoom in by clicking the chromosome number, and in this zoomed in plot you can see several details. For example, you can kind of see there's something going on here, but maybe we're a bit too zoomed out to see. So what we can do is we can mark that, just put some 0 breakpoints annotation next to it, and then when we zoom in it'll be easy to locate that spot and try to check if there's something there later. So let's zoom in just a bit using this iPad zoom level, and in this zoom level it's clear that we can see this amplification here. So you can just verify the breakpoints there if we want, and then here we can label this as an amplification. Interestingly enough, you can also zoom in to the ucsc genome browser to verify if there's any interesting genes in that region. And going to the ucsc genome browser window, you see that indeed there's a McN gene in this region. So yeah, again what I did is I shift clicked the annotation to zoom to the ucsc genome browser. And we can zoom in to the rest of the profile to see if you can see anything. And so at this zoom level it seems pretty clear there's something going on here again, but still not zoomed in enough. So what we can do is we can use the 5 pixels per probe zoom level, and again zoom over to see that annotation we got. And here, yeah, so here we can see that the segmentation did not pick up on this by default, but by adding a couple of 1 breakpoints annotations we will be able to clearly annotate this. And so I'm going to call this a deletion. And so we can zoom back out to the profile, and then we see that adding that annotation here introduce some breakpoints here. Maybe we don't want that, so let's just add a 0 breakpoints annotation. Do you see that changed the breakpoint lines to purple? And what that means is that only the annotated breakpoints are present in the segmentation model. So only the 2 breaks here and the 2 breaks here are actually present now. Okay, zooming back out, profile view. Well, we can zoom into chromosome 8 and verify this is good. Yeah, seems that correctly annotated that deletion. Zoom into chromosome 11. I see I have a deletion here and a loss region here. That's good. Zoom into chromosome 15. It seems like it calls this as a breakpoint, but we can correct that if we think it's not a breakpoint. Same thing with chromosome 16. Oh, well, it seems like that's a small deleted region. Can maybe zoom in to verify. Yeah, again, what we can do to verify is we can place some kind of annotation in the region and then use the 5 pixels per probe zoom level to go in and find that. And yeah, it indeed looks like a deletion region, and we can confirm that by adding a couple 1 breakpoint annotations. Zooming back out, let's go to chromosome 17. And yeah, it sees there's 2 breaks here, but I think maybe there should only be 1 break, so let's enable that. Okay, so it seems like this profile is fully annotated now. So now we can show the alterations on the ucsc genome browser. And so what this does is use a list of all these alterations that we just made. We just annotated, and so we can send your annotations and model to ucsc, and this will allow us to visualize the genes that were involved in the amplifications and deletions and losses that we just annotated. So it takes a couple of seconds to transfer the data, but then once it's transferred, you get a list of all of the different custom tracks that you've loaded so far. So what I'm going to do is just check all and delete all of the other tracks except for the ones that we just did. Okay, and then I'm going to go back to this list and maybe show you a couple of interesting alterations. Now, we already looked at that amplification in the McN gene by just shift clicking the annotation we created. Let's look at this deletion region and see if there's anything in there. So it looks like this small deletion that we annotated doesn't seem like there's any genes in this region, but maybe on our chromosome 8, is there something going on here? No, nothing here either. Chromosome 11. Yeah, so on chromosome 11 it looks like there's some interesting OR4P4 or 4 other genes, and so you can very clearly see this is the probe log ratio measurement signal, and this is the segmentation model. The black regions show a higher average value, and the white regions show a lower average value. These are the annotated breakpoint locations in the model. These are the represented by the vertical dashed lines on the plots. And then this last copies track, this shows you the copy number calls of the model. The yellow means normal and the blue means deletion. So we very clearly see that the deletion is localized in this family of genes. Clicking the genes shows that this is an olfactory receptor.